Students, what have you observed? The rubber band stretches when being pulled and regains its original length when released at one end. The band had acquired energy in its stretch position. How did it acquire energy when stretched? Well, let us find the answer to this question. As we can see that the rubber band is being stretched, that is, work is being done on the rubber band. Also, we know that when a work is being done on an object, it gains energy. So here the energy is transferred to the band from the hands by pulling the rubber band. The energy is then stored as potential energy. Similarly, in this case, when you pull a slinky by your hands, it acquires energy, and on pulling, this energy is stored in the slinky in the form of potential energy. Also, when the bow is pulled back by stretching the string, potential energy is stored in the bow due to the change of the shape and thus used in the form of kinetic energy in throwing of the arrow. Hence, we can say that the potential energy possessed by the object is the energy present in it by virtue of its position or configuration. Now, let us see the potential energy of an object at a height. We see that a bob is kept at a height, say 10 cm above the base of the stand. And bob number 2 is kept at a height, say 18 cm above the base. Can you see which bob possesses higher potential energy? It is bob number 2. Since bob number 2 is at a greater height than bob number 1, and since an object increases its energy when raised through a height. This is because work is done on it against gravity while it is being raised. Similarly, when a bucket filled with water is lifted, work is done on it against gravity while it is being raised. So, the energy present in such an object is the gravitational potential energy. Let us see the expression for the gravitational potential energy of an object at a height. Consider an object of mass m. Let it be raised through a height h from the ground. The minimum force required to raise the object is equal to the weight of an object, mg. So, the work done on the object against gravity is work equal to force into displacement, which is equal to mg into h, which is equal to mgh, where m is the mass, g is the gravitational force, and h is the height of the object from the ground. Therefore, work done on the object is equal to the energy gained, that is, potential energy. So, potential energy, EP, is equal to mgh. John is at a height of 3 meters above the ground. He throws the ball downwards in a straight line. Whereas, in the second case, the ball is thrown in a curved path. So, what can you say about the potential energy possessed by the ball in both the cases? In the two examples shown, the box is raised to a height h in two different parts. What is the work done in both the situation? Is it same? Yes, the work done in both the situation is mgh. This is because the work done by gravity depends on the difference in vertical heights of the initial and final position of the object, and not on the path along which it is moved. I hope that you've learned something new about potential energy and you have enjoyed this video.